All right, so let's fill in notes about piecewise functions and talk a little bit about them. So if you notice, first up is just an example of how a piecewise function is used, and we tried to use a situation that would be familiar to you. So if you notice, okay, we are good. If you notice, it has to do with charges for a cell phone. So it says a telephone company offers the following plan. So $20 per month buys 60 minutes of time, and then any additional time costs 40 cents per minute. So I need you to think first about how we represent this $20 per month by 60 minutes. So that's this part of that piecewise function, this first statement. So if you notice, this is just a constant. It's just a flat fee of $20 up to and including 60 minutes. But beyond that, if you notice, additional time costs 40 cents per minute. So this is saying, this is the second equation to represent that situation beyond 60 minutes. So we still pay that $20 plus 40 cents for any minute. This subtraction here would figure out how many minutes beyond 60 you've gone to help you determine how much you would pay. So what this is asking for, this first little bit, it's asking, and it says find and interpret each of the following. So it's saying, what is C of 30? So now what that means basically is we can plug in 30 into the equation, but we need to know which equation to plug into. So we have to think about where that fits in, whether that is within this interval or within this interval. In other words, this is an x value of 30, or t in this case, a time of 30. This is saying you would be using your phone for 30 minutes. So obviously, if you think about it, we're going to have to use this first inequality or this first statement to represent that situation. So what that tells us is if we talk for 30 minutes, then we are only going to have to pay $20. Whereas if we have to plug in, if we talk for 100 minutes, that means we have to plug into this inequality right here. So we're plugging into this, and we have to this equation. So 20 plus, or this expression, 20 plus 0.40 times 100 minus 60. And so we do 20 plus 0.40 times 40. So we get 20 plus, and if we multiply 4 times 4 is 16. And if we add the 2 zeros, but then we move the decimal, we get 16. So we find that the cost would be $36 for that particular situation. So that's just a representation of how we might, a type of an example where we see a piecewise function and how we would evaluate. We also need to talk about actually graphing. And so let's take a look at those. So I'm going to show you kind of two different ways to think through these. Everyone's a little bit different in terms of the process that they prefer. So for some people, they prefer to truly draw the entire graph and then go back and erase the part that needs to be eliminated. So I want to graph, if you notice, we have these two parts. I want to graph the graph of 3x minus 1. So I'm going to graph that. I'm going to start at -1, and I'm graphing a slope of 3. So I'm going to go up 3 and over 1, up 3 and over 1. From this same point, I can go down 3 and left 1. And so I can draw this line. Sorry, not very straight, but you get the general idea. So now we've got to go back and we've got to look at this part of the equation where it's saying if x is less than or equal to 1. So what that's telling us is that we want to go to where x is 1, and we want to find that particular point, and we're going to include that point because of the less than or equal to, the line underneath. And we're looking at everything that is to the left of that or less than that. So that would be this part of the graph. Now what that means is that I'm going to go back and I'm going to erase this part of the graph. So I've drawn the full graph, but now I've gone back and erased the little bit that we need to get rid of. Okay, so but now let's go on and graph the second part of this graph. So let's graph y is equal to 4. So y is equal to 4 means we have a horizontal line 4 units above the x-axis, so that would be a line about right there. But once again, we need to go consider this restriction here. That's the piecewise part. So this is saying at x equals 1. So where the graph is at x equals 1, what's the y coordinate? Now because it's greater than and not greater than or equal to, we need an open circle there. And greater than 1 means it's going in this particular direction. So what that means is that we need to go back and erase this part of the graph. Voila, there's our graph. Now, we need to decide on the domain and the range. And I've kind of erased that little circle, and I want to be clear that that's an open circle there, that's a closed circle there at the green. So to state the domain, we need to decide if there are any places where there are any gaps or points that are not included. The tendency is to think that there should be a break in the domain, but because we have at this particular location in this line that I've drawn, if you notice, we hit a point on the graph. So there's no break, there's no other point. We're hitting points from left to right on this particular part of the graph, but at that one location, we still hit a point on the green part of the graph. We're not hitting anything on the purple. But then when I continue to draw lines going from left to right, I'm still hitting points. So what that's really telling us is that our domain, it seems strange, but our domain is actually from negative infinity up to positive infinity. Now to decide on our range, we need to draw lines kind of going the other direction from low to high. So if we draw points, going in this direction, I want to do it in a different color. So from low to high, we're hitting points all the way up to this location. So if you notice, that's saying that we are going from negative infinity up to and including the point 2. And then we're going to union that, because if you notice, then we start, there is a section here where I'm drawing lines going across, but I'm not hitting any point of the graph. And then I hit this point at 4 where I keep hitting a whole bunch of points at that same value. So different mathematicians and different math teachers decide to represent this in a little bit different way, but usually if it's just a single point like that, I write that in interval notation as brackets, just the single number to show it's just that single value at 4. Okay, all right, and now let's take a look at this one. I'm going to make it a little bit bigger so it's a little bit easier to see. I'm going to graph this one strictly by just looking at points, except for obviously this part here where we're drawing our line. So the first part of this graph, we're just graphing the graph of y is equal to -3, but I'm going to take into account this if x is less than -2 to begin with. And so at the point -2, -3, I'm going to draw an open circle there. And I'm going to draw that graph. I know I need to draw the graph of y is equal to -3. And it's going to have to go in the less than or the left direction. Okay? And then lastly, to graph this second part of this graph, this x minus 3, I want to plug in -2. It's equal to -2. If we plug in -2 at this particular value, I want to include whatever that point is. So if I plug -2 minus 3, then I get -5. So at the point -2, 1, 2, 3, 4, 5, I need a closed circle to show that it's included. That's what this greater than or equal to is saying. We know we're going to be drawing a line some to the right of that particular value. And at this point, I just want to look at what the slope is. So I have a point on my line, and I know my slope is 1x, which just means I'm going up 1 over 1, up 1 over 1, up 1 over 1, and so on. And you can kind of check and verify on this one. What's nice is that you can check and verify that this graph is crossing at -3. But I'm just going to draw in this part. No need for me to draw the full thing and then erase part of it. So there's my graph. Let's talk domain and range. Once again, if we draw points from smallest to largest, so left to right for domain, there's no break. There's no place where we do not hit a point. So what that's telling us is that our domain is from -infinity to +infinity. Our range is a little bit different. If we are drawing our range, if we start low, I'm not hitting points until this spot, and I keep hitting points. Even at -3, I'm hitting a whole bunch of points, but I continue to hit points. There's no break all the way up to +infinity. So my range is from -5, and we include that point, so we'd use our bracket all the way up to +infinity. All right, you're gonna get to do a little bit more practice with those piecewise functions. I'm excited.